Sorry about that, everybody. Okay, so intermolecular forces, inter, that part of the word means between, and molecular, molecules, forces, so this is a force of attraction between molecules. So in other words, between molecules. So this is a temporary attraction that occurs between an area of high electron density on one molecule and low electron density on the other. And these exist between liquid and solid molecules. And this is why something like water, which has a really low, relatively low molecular weight, exists as a liquid, because the force of attraction between two water molecules is so strong that the water molecules stay together. They're dense. It's dense as a liquid, and that's why it doesn't exist as a gas in room temperature. So intermolecular forces hold molecules together, and there are a lot of implications of having stronger intermolecular forces. For example, molecules with strong intermolecular forces, that means a lot of energy is required to break those intermolecular forces. So stronger intermolecular forces means that molecule or that substance would have a higher boiling point, because those forces of attraction need to be broken for something to boil and become a gas. This image here shows two ethanol molecules. I'll draw in the atoms here. So this is oxygen in red, bonded to a hydrogen. The black atom is carbon, and that's bonded to 3 other hydrogens. So this is showing we have 2 molecules that have covalent bonds, but the hydrogen from one is attracted to the oxygen from the other, and the force of attraction between them is an intermolecular force, a force between the 2 molecules. Okay, we have 4 types of intermolecular forces. This provides an overview, and then I'll go into more detail about the 3 on the right. Ion dipole is an attraction between an ion, so a formally charged ion, and a molecule that is polar. So this example here shows a cation, positive charge up here, anion down here, in water. So the red and white represents water. And this we briefly talked about last term, but if we have water, remember water is polar, oxygen has partial negative charge, it's more electronegative than hydrogen. Hydrogen has a partial positive charge. So the partial negative part of water is attracted to this cation that's in solution. So the attraction between the molecule and the cation is an ion dipole force. And then the same but opposite is true for an anion in solution that would be attracted in water, in the case of water, attracted to the hydrogens in water. And this is why ionic compounds dissolve in water. The water surrounds the ions. Okay, so that's first. Next is hydrogen bonding. So we don't have any formal ions here, no cations or anions, but we have very polar molecules. So a molecule with a hydrogen bonded to a nitrogen, oxygen, or fluorine results in a hydrogen bonding interaction. So the example here is NH3. The NH bond is polar, partial positive near hydrogen, partial negative near nitrogen. So positive hydrogen, force of attraction to the partial negative nitrogen. So this occurs in water, hydrogen fluoride, NH3, other molecules that have hydrogen bonded to oxygen, fluorine, or nitrogen. Dipole-dipole interactions are when you have polar molecules, but the polarity is not under the hydrogen bonding umbrella, so it's not a hydrogen bonded to nitrogen, oxygen, or fluorine, but you still have a polar molecule. So this example is hydrogen chloride, HCl. Chlorine is more electronegative than than hydrogen. So we have a partial negative charge on the chlorine, partial positive on hydrogen. Well, the partial negative on one HCl molecule is attracted to the partial positive on another HCl molecule. So that force of attraction is dipole-dipole. So HCl is an example. CF4 is not an example. Cross that one out. CF4 is a nonpolar molecule, so that doesn't work here. But CH2Cl2 does work. Lastly, we've got dispersion forces. These are forces of attraction between nonpolar molecules. So we usually don't think of partial positive or negative when we're talking about nonpolar molecules, but in a molecule, the electrons that are in valence shells can shift around throughout the molecule, and if they shift more to one side, that induces a temporary dipole in the molecule. So here they're showing electrons shifting to the left. That creates a partial negative and partial positive, which is then distorting or creating another dipole in another molecule so that positive and negative are now closer to each other. So the electrons over here would then be attracted to the partial positive side there. So any nonpolar molecule has dispersion forces. Now these are the weakest, and these are the strongest. All right, one eye clicker for you all. You are looking at a list of molecules, and you are selecting any, there may be more than one option, but you can only select one. Any molecule that can have hydrogen bonding interactions between molecules, assuming it's a pure substance. So if you have the first molecule, CH3NH2, if you have that and more of those molecules, can those have a hydrogen bond? CH3CH2OH, that's ethanol. If you have ethanol and more ethanol, can those hydrogen bond? Methane, HCl, etc. It might. Do you have the app on your phone? So I noticed that earlier had that issue, and when they logged in on their phone, I think that's what was happening. Then it worked. You also have to allow location. You did. Okay.
You could have from C minus.
That's all for today. We'll talk about this when we start class Friday. Yeah.
Record it.
Yes.
I don't know. I mean, did you like post it on Blackboard? 'Cause I'm not.
Yeah, let me show you. Let me stop recording.